Hey everyone. So welcome back. There's not really any new instruction in this video, but what we will be doing, or what the objective and purpose of this video is to really talk about some of the IB language. Look at some of the questions. I mean, you just finished your first IB problem, and as strange as it probably was for every single one of you, we basically told you don't study, right? That we weren't going to provide you a list of what these words mean because a lot of it is learning by immersing yourself into it. So now that you've taken that one and you've had an opportunity to see one and talk through it and see some of the language, we want to go back and now analyze some of that language and see what happens when people take different pathways, and how different points are awarded through IB so that you can begin to kind of develop an understanding of this, which is a learning process. Okay, so as we go through this, you guys have access to this PowerPoint, but you also have access to the guided reading that I'm going to go through, and the quality of it isn't great, but the content of it is, so I didn't modify it, as well as the IB guided reading questions, which are on this, right? So you'll see those on a Kami assignment, which you'll submit at the end. So with that being said, let's get started. So first of all, you see this, right? So composite, and this is really focused on what we've learned. So you can kind of see what IB wants. So composite and inverse functions, you should be able to, right? And think about all the things you can do. Check it off. Find the composition of two functions. Y'all can do that. Find the value of composition of two functions, particular value of x. That's like saying like f of g of 2, right? Use the graph of a function to decide whether the function has an inverse. Ooh, right? Like, is that function one-to-one? Does it pass what we've been referring to as the horizontal line test? Sketch the graph of an inverse function from the graph of a function, right? So this is the idea of switching the variables, right? See how much we've already learned? Can you verify that two functions are inverses of each other, right? And whether you're using algebra or composition, we've learned a variety of ways to do that. You should know. So these are like the things you should be able to do. What should you know? What facts should you know? The composition function f of g can be denoted either one of these two ways, right? So that's why we've been exposing you to multiple ones. The composition f of g is the operation of applying g and then f, right? Starting from the inside, and then g of f is the operation of applying f and then g. If f is a function that maps x to f of x, then the inverse function f inverse maps f of x back onto x, right? So you're undoing it. So if this is a function, if this was my input and this is my output, this is my domain, this is my range, it switches. Let's see, geometrically, the graph of an inverse function is a reflection of the original function over the line y equals x, right? That was one of our fun facts. The domain of f is the range of f inverse. The range of f is the domain of f inverse, right? So there's a lot of connections here. To find the inverse of a function analytically, simply switch the position of x and y and then solve the resulting equation, right? We did a lot of this, right? We did inverses using composition to verify, and then we did it solving it algebraically or analytically. So good word. Let's see what else. A function g of x is the inverse of f of x if and only if, composition, right? That was one of the ways. Let's see. Right, and then we've got some examples over here which you can take a look at. So f of x equals 2x, g of x equals 1 over x minus 3, where x does not equal 3, right? Oh, look, didn't we tell you guys to get into that habit? Find f of g of x. I'm sorry, f of g of 4. Since f of g of 4 equals f of g of 4, and then evaluate g of 4 first, and then substitute the result into f of x, and you can see that process. Find g inverse of x. Well, you can switch the x and y. And notice what these are all have there. G inverse, you can switch and solve and use the appropriate notation, right? So like this was our notation. This is the notation we ended up with. Note that g inverse of x is undefined when x equals 0. So the domain of g inverse includes all real numbers except for 0. Be prepared. The order in which the functions are to be composed is extremely important. So pay attention to that, read carefully. Proceed with caution when simplifying expressions resulting from a composition, right? So this is not news to us, right? Like we've been talking about this. So this is actually a problem that you saw on the IB problem, right? On the IB problems that you guys completed. And it might be that you get caught up in something like this, but it doesn't really impact it, right? We don't care about this part because we're given a graph, right? No, we haven't learned what e to the power of 0.5x looks like, and nor were you expected to for this IB problem. So let f be this function. Oh, look, here's f. Between 0 and 3.5. Oh, that's fine. It's between 0 and 3.5, right? Those are my x values. The diagram shows the graph of f. On the same diagram, sketch the graph of f inverse. It is 3 marks. Pay attention to how many points it is, right? That's important. That is very important to us. So that means that it's going to require a little bit more work. This one right here says, write down the graph of f inverse. It's only 1 mark. Write down, this word right here means no work needs to be shown. That likely means that there's not much that needs to go into it to arrive at an answer. It doesn't mean I'm going to do all my work and then just circle my answer. Like if you're doing all of this process to get there, something's not right, right? It is only 1 mark. Use these points to guide how long you're spending on something, right? And this is a great thing for the test as well. Like we do incorporate IB language and all of that stuff into this. So make sure that you're taking a look at this terminology and make sure you're always looking at the point values. Okay. So here is something, and this is very blurry, I apologize, but it's okay. So you can see, here is someone's work, right? You can see what they did here, and then let's look at what they wrote. So like this is their A, this is their B, this is their C. So you can see what were they awarded points for. So A was 3 points. Although not fully correct, the graph shows an approximate correct shape of a reflection over the line y equals x. So they were awarded 2 points here, right? They got 2 here, right here. The endpoints have not been plotted carefully, right? If you're someone that is not plotting things carefully, look, this was 0, 1. I need this point over here. If this point was, we knew it was 3.5, about 5.5, then I need to be sketching it a little bit more carefully, right? So they have the approximate shape, they know something, but they're not being careful. The y-intercept, right, so it's talking about that, reflected, the inverse, the coordinate point switch, it needs to be reflected, but here it has been plotted at the closer to 6, 2.5. Okay, so let's see, what does this say? This one, they have B, I don't even think they have an answer, right? Yeah, I don't think they have an answer. For C, that one was 3 steps, right? And it said find. And this one was just the domain. Why didn't they do it? Interesting. This one said to find the inverse, right? And that was something that we won't learn until 2nd semester, which is fine. But the idea of it, y'all can do and are capable of doing. A correct answer with no work shown only earns 1 mark out of 3. Isn't that interesting? So even though their answer might be correct, they're only awarded 1 point, right? So a big thing, if the student has not crossed out his work, full marks would have been awarded. So them crossing this out made them lose 2 points. So even if you know an answer straight away, unless it is a write down question, you should always show some mathematical work that leads to the answer. Always. The only time you do not need to do that is when it's a write down question, when it is 1 point. Okay, so think about this person could have gotten 2 points back here. Let's look at another one. Let's see what this person did. You can see, sorry, I should have showed that at the top. Oh, did I cut it off? How many points it is? I think it's on the paper, but I must have cut it off. So this person got a 4 out of 7 on this. So let's see what happens. So they did not reflect this over the correct axis, right? So like they got no points here. It's just not right. Their range that they wrote down is accurate for what they did here. So this FT means follow through. So that's a hard one for us because we're not writing on a lot of your papers, but sometimes you would see something that says follow through. It doesn't mean you got the answer correct, but you got the correct answer based off of something that you may have done incorrect. So that is a good thing to think about. Like you knew the process, but you had an issue earlier on. So you won't be penalized if like you're struggling. Give me something, give us something, and then keep moving on. So -5, the range would be -5.5 to -1 based off of this. So then they went ahead and they found the inverse, and you can see that they got 3 points for that, right? So they did the entire thing and they showed the process. Based on the incorrect A, the correct was written, and so that's what FT means, follow through. To find the inverse of X and Y, you interchange the X and Y, although 2 ln x or ln x squared would be a preferable answer. The student has written in an equivalent alternative form. See that? Like you can have, some of you guys have asked that question, like, well, what if I express my answer like this? It's equivalent, and that is fine. Okay? Unless it tells you to be in a specific form. So this person got 4 points. This person got 6. Let's check out what they did. So being attentive to the endpoints, right? So they've got the correct endpoints sketched. They got all 3 of those points in the shape. Their range, awesome. They showed the work. Let's see. They didn't, what happened here? They, ln of x. I think they're, so they lost. Where'd they lose their point? Oh, here. Oh, yeah. That's not their range, right? It should have gone from 0 to like 3 point, what was it, 5? So that's where they lost their point, and then they're good here. So using that fun fact of inverse is there to switch X and Y. You'll learn about logs and ln and e to the power of something this year, second semester. So now that we've kind of talked through some of these things, make sure that you are completing those guided reading questions on Kami. It is really good to analyze some of these languages and previous assessments of IB tests and student work. It is very useful, and we try to incorporate it as much as we can so you guys have exposure to it starting now. So go ahead and complete those and make sure you submit the Kami. There's like a little submit button that sometimes students have trouble finding. You have access to these questions, and you also have access to this reading that I encourage you to maybe download it and keep it somewhere so you have it in your own files as well, because it is a great thing to go back and reference. Other than that, make sure that you finish your little book and submit your video before we see you for your test, and do what you need to do to study. So I will see you all next time. Great job.